Okay, y'all. Sorry, my son just missed his chair and I could hear it. He almost fell. It's kind of funny. He's okay though, I promise. Okay, so we are actually going to start 6.5, which is determinant and Kramer's rule. I've got a lot of stuff written right here. Let's go ahead and just kind of read over it. Let me flip my laptop real quick. Oh, I'm so thirsty. Oh, I hate it when it does that. Oh, wow. Okay, hold on. Okay. So, okay, now let's start. Let me just kind of go ahead and define what a 2 by 2, that's what that X means, 2 by 2 matrix is. It's in the form A1, B1, A2, B2, and this is actually going to be an array of terms, technically. So I think a more common way would be what you see right here, which is A, B, C, D, right? And so the reason why this is a 2 by 2, how small is this? So they're talking about the rows and the columns. This would be row, it's hard to write. This would be row 1. This would be row 2. This would be column 1. This would be a column 2. Right here, that's our row by our column. So this is saying row by column, which is 2 row, 2 column, 2 by 2. Okay. The technical, real mathy, and what you might see in the help is going to be A1, B1, A2, B2. Usually, I think it's more common. And what I am used to writing is just a matrix in the form of A, B, C, D. Now, the way that we find a determinant of a 2 by 2 matrix is notice that I started with brackets, right above me whenever I define the 2 by 2 matrix. And then for the determinant, I now just have just straight lines, right? Just bars. They almost look like absolute value bars in a way, but they're no longer brackets. Okay, that tells me, oh, okay, I'm taking the determinant of it. And the way you take the determinant of a 2 by 2 matrix is you multiply A1 with B2. You subtract from that the product of A2 and B1. Okay, so again, more common, this is going to be more along the lines of how I would write it, how I would say it. Why does it only highlight that one? I'm going to go ahead and erase all that out. Okay, and so what it is, the determinant of A, B, C, D is AD minus BC. A times D minus B times C. So what we're doing here is we're finding the difference of the product of the two diagonals, right? Here's a diagonal, and here's a diagonal. So we're going to find the difference, right, of the product of the two diagonals. If this is a diagonal, I'm going to take their product, which is A times D, and then here's my second diagonal. So I'm going to take the product BC, CB. It really doesn't matter in which form you write your multiplication, only because multiplication is commutative, but you do have to do the AD first because I'm actually subtracting the product of BC. If you flipped these, you would get the incorrect answer, okay? Okay, so let's go ahead and let's just, simply evaluate the determinant of these two 2 by 2. Oh, it's matrix when you're speaking of just a single matrix. It's matrices whenever you speak of more than one matrix, okay? So let's evaluate the determinant of these matrices. So, I want to do dark blue. I see here that for problem 1, I have the 2 by 2 matrix 2, 4, -3, -5, right? Well, if I'm going to actually take the determinant, which can just be notated with a capital D, okay? I don't know where those came from. Which can just be notated with a capital D. What I'm going to do, I'm going to lose the brackets, and I just have 2, 4, -3, -5. Okay, well, I know that I'm going to do A times D minus B times C. My A is 2. My D is a -5. I'm going to subtract from that my B times C, right? But I'm going to do -3 in parentheses. Then I'm going to multiply that by 4, 2 times 5, and then 3 times 4, yes. Okay, and so just doing the little math right here, y'all, for that first multiplication, I need to close this more so I can write better. Oh, give me a second. I'm going to adjust my pillows. Okay, let me see if I can do this a little bit better now. So doing that multiplication from those first two values, I get 2 times 5 is 10. Signs are different, so it's negative. And then looking right here, what I have is 3 times 4 is 12. Signs are different, so it's negative. Multiplied by that negative gives me a positive 12. Okay, and then just finishing this right here, what I notice is that my signs are different. So what I'm going to do is subtract, keep the sign of the larger, and this right here is what the determinant is of that 2 by 2 matrix. Okay, now let's do this one. Drop my brackets, 3, -3, -2, 6, close. Okay, and what I do is 3 times a -6, subtract from that a -2 times a -3. 6 times 3 is 18. Signs are different, so it's negative. 2 times 3 is 6. Signs are the same, so it's positive. And then that negative makes it a -6. Because these signs are the same, what I'm going to do is I'm just going to add them, and I'm going to keep their sign. So the determinant for this 2 by 2 matrix is a -24. Okay, so that's how you find the determinant, okay? Now, let's go ahead and let's look at, it won't let me zoom out. All right. There we go. Nope, not yet. I closed my laptop like all the way, and I'm trying to look at it from bird's eye view. Okay, here we go. Let's go ahead and define Cramer's rule. We use Cramer's rule whenever we're solving a linear system in 2 variables, and we do this using determinants. So if you look right here on the left, it says if a sub 1 times x plus b sub 1 times x equals c sub 1, that should be y, because obviously x, y variables. So let's go ahead. Oh, it won't let me. Thought I was being real fancy, writing everything first. Right, x and y, okay? And then for that second equation, I have a sub 2 times x plus a sub 2, y equals c sub 2. Those subscripts 1 and 2 just mean that, this is my first equation, that's my second equation. That's just kind of how you know where it came from, as well as its place in this form right here, those forms, okay? So if those equations are there, if that's what we have, then the way we solve for x is to actually find the determinant of c sub 1, b sub 1, c sub 2, b sub 2, divided by the determinant of a sub 1, b sub 1, a sub 2, b sub 2. And then the way we find y, our denominator is the same, but our numerator is different. Now it's the determinant of a sub 1, c sub 1, and a sub 2, c sub 2. And this is where our both of our denominators here, which is a sub 1, b sub 1, a sub 2, b sub 2, does not equal 0, okay? This means that we can use the Cramer's rule because the determinant does not equal 0, as well as if you notice it's in a denominator form and you can't divide by 0, so that's another reason as well. So let's go ahead and do one of these problems, and then what I'm going to do is go ahead and start another video, because if not, it just starts taking too long, okay? Hopefully this one doesn't take as long. Okay, so I noticed, let me see, I want to go ahead and point out this. So this form that we have here is the same form that I have written for my problem. The only difference is I'm going to actually have an equal, and then I've got a C sub 1 and a C sub 2, right? But I still have this form right here that I just highlighted. And I was told that the way you find the determinant is to actually, well, let's go ahead and say we could do this as well. Either of those are the same, right? That's how you find the determinant. A sub 1, B sub 1, A sub 2, B sub 2, right? So knowing that, the first thing I want to do whenever I try to solve this problem, because I notice here, that's the determinant, right? A sub 1, B sub 1, A sub 2, B sub 2, that's the determinant. First, let me find that determinant, okay? So for problem 1, what I have is x plus y equals 4, then x minus y equals 2. Okay, if you want, we could go ahead and this would be my A column. This would be my B column, right? This would be my C column. Do you agree with me? This would be my first equation on the top, right? Let me go ahead and show you how to find the determinant, and then we'll just kind of move along, trying to think of like all the different ways I can say this. So, nope. My determinant, right, is going to be found by taking my A sub 1, B sub 1, A sub 2, B sub 2. A sub 1 is right here, right? What's that coefficient? So that coefficient is a 1. B sub 1, coefficient is a 1. A sub 2, coefficient is a 1. B sub 2, coefficient is a negative 1. Do y'all see that? Now let me go ahead and use that information and find its determinant. I would do 1 times negative 1, subtract from that 1 times 1. Okay, so what I get here, I get 1 times 1 is 1. Signs are different, so it's negative. And then I have 1 times 1 is 1. Those signs are also different, so it's negative. Because those signs are the same, what I get, what just deleted? I'm trying to delete this. I didn't want to do an arrow. This is aggravating me. Y'all. Gotta chunk this laptop. I pushed a button, I'm guessing. Okay. See how it like deleted that second set of ones? I think that's where I pushed some weird button. We're going to subtract from that this diagonal. Nope, that was the first one. This diagonal. So we do 1 times 1. Solving this, left-hand side, 1 times 1 is 1. Signs are different, so it's negative. Right-hand side, 1 times 1 is 1. Signs are different, so it's negative. Those signs are the same. So what you do is you add and you keep their sign. This is my determinant. Goodness gracious. Okay, now, y'all, do you agree with me? My determinant does not equal 0, right? Okay, that's great, because that means I can use Kramer's rule. So let's go ahead and let's find our x first. So to find my x, what I do is C sub 1, B sub 1 over C sub 2, B sub 2. So use your bars right here. I guess that's kind of needs to be a little bit lower. Okay, so identifying those, I'm trying to think if I should just go ahead and show this. Let's go ahead. It's just this is saying a 2 by 2. I don't really want to write this one thing down yet because it's not how they're showing it to y'all. So we'll just keep moving on, okay? So knowing that it tells me to do, y'all, I'm going to stop. I'm going to drop some of the subs, okay? CB, CB, C sub 1. This would be my first equation, so that would be 4. Yeah. Okay, and then to do B sub 1, I would get a 1. And then C sub 2, I get a 2. And then B sub 2, I get a negative 1. Okay, hopefully y'all understand where all those came from. If you don't, make sure you let me know. Okay, and then my determinant. So you can go ahead and actually write the determinant, right, like everything. But the fact that we just found it right here means that all I really need to do is just write negative 2 over it. Unless you want to find it in this way and not find it separate like that, okay? So that's going to be how I find what my x value is. So let me go ahead and solve this. Those straight lines, those bars mean to take the determinant, and I'm going to take the product of the diagonals, right? And so I would get 4 times negative 1, subtract from that 2 times 1. Oh, I did it again. I wonder what it's going to do. I pushed the button again. Close that. Divided by negative 2 equals. Now looking at this, I have 4 times 1 is 4. Signs are different, so it's negative. 2 times 1 is 2. Signs are different, so it's negative, right? Then over negative 2 equals. So 4 and 2 are both the same sign. So what you do is you add, keep the sign, divided by negative 2. 6 divided by 2 is 3. Signs are the same, so it's positive. That's my x. Okay, now let's do the y. My y tells me that the values that I'm pulling are my a's and my c's. So like that would be my a's, 1 and 1, right? And then my c's are right here. That's 4 and 2. Divided by the determinant, which was negative 2. Find the determinant of our numerator. We have 1 times 2. Subtract away from that. 1 times 4. Divide that by negative 2. 1 times 2 is 2. Signs are the same, so it's positive. 1 times 4 is 4. Signs are different, so it's negative. Divide by negative 2. In the numerator, I have 2 minus 4. Those signs are different, right? So I subtract, keep the sign of the larger. I'm dividing that by negative 2 right here. 2 divided by 2 is 1. Signs are the same, so it's positive. That is my y. So this, oh my goodness. I keep thinking I'm holding the pen right, but I guess I'm not. See how weird it starts acting? It's about to go away for a second, I bet. Told you. Watch it. Oh, did it work? Nope. Sorry, y'all. That's like from 2016. Go lines. Any day now. Scroll on down. Your answer that you get for your x and your y. It's my y. What we're going to do is actually write it as x, y. That's your answer. Okay. So let me look at my notes really quick. That's a positive 3. That's a positive 1. Okay, so x is 3, y is 1, right? If you look right here, x being 3, y being 1, 3 plus 1 is 4, right? You can go back and check your answers. Okay, so pretty sure this video has been lasting like 73 years. So I'm going to go ahead and turn this one off, and then we will come back and we will do, we're going to look at a 3 by 3 matrix and how to actually take the determinant of a 3 by 3 matrix using I forgot if it's small determinants or little determinants. What do we call them? Minor. By using minor determinants. Let me see. Oh, wow. Yep, that's it. I'm going to go and sign off. Thanks, y'all. If you have any questions, make sure you ask. Bye.